Good afternoon, students. I hope you must completed Unit 3 and 4. Now we are starting from the very first chapter of the 12th class syllabus, that is relation and function. Now, dear student, I am telling you this is about, it is only the theoretical chapter. There is no any formula is not there. Only in this chapter we have to study the theoretical portion of the mathematics. There is no plus, no minus, no multiplication, but only the concept is there that you have to keep in mind. In the 11th class also we have introduced about the relation and function. You can easily recall it or not, and me I going to recall you about the topic relation and function. Let me introduce it. Very much interesting. Now here the word that we have done in the 11th class also, the Cartesian product of two sets. Let me explain it. Let A and B be two non-empty sets. Then the Cartesian product of A and B denoted by A cross B. It is a set of ordered pair. It is a set of what? Ordered pair. Now in the relation and function, in the whole chapter we only studied not the single element. We always studied the ordered pair of elements. Now A cross B. It is a Cartesian product of A and B. A cross B, the set of ordered pair AB, where first elements belongs to A and the second elements belongs to B. So this is what? A cross B. Similarly, B cross A can be written as BA. The first element is from B and the second element from A. So this is what A cross B, this is what B cross A. Let us form it. Let A the set having element 1, 2, 3. B the set having element XY. Let make all the possible ordered pair. So first I am taking the element, first element A cross B, first element I have to take from A. So it may be 1x, it may be 2x, it may be 3x, it may be 1y, 2y and 3y. I have written all the possible ordered pair that is possible from A to B. It can be written as 1x, 1y, 2x, 2y, 3x, 3y. So set of what? Ordered pair. It is what? A cross B. First element is from A and the second element from B. Now conversely, B cross A. The first element from B, second element from A. So it may be x1, x2, x3. Under it may be y1, y2 and y3. This is what? B cross A. If A and B are not equal, then A cross B can never be equal to B cross A. In generally, A cross B is not equal to B cross A. Now the second is, if A cross B equal to phi, then when it is possible either A or B or both A and B are empty set, because phi is the sign for empty set. If A cross B is phi, then either A is phi or B is phi or both A and B are phi. Let A set 1, 2, 3, B is phi, then A cross B must be equal to phi, because there is no any element in B. There is no possibility of making the ordered pair. If one of the sets or both the sets are empty, then A cross B, or you can say these are always phi. Now here the one of the important result, the number of A cross B equal to number of A into number of B. Here the number of A is 3, here the number of B is 2. So number of A cross B will be 3 into 2 will be 6. So 1, 2, 3, 4, 5, 6. So we can say number of A cross B equal to number of A into number of B. This we have done in the 11th class. I have introduced again what is the Cartesian product of two sets. Now the word is very much important. The word is relation. Now you know the meaning of, literally you know the meaning of relation. The relation exists between always between two objects. Always we are having the relation between the all the members of a family. There may be relation between members of two family also. Similarly, it is again mass we are having the relation between the elements of one set or between the element of two non-empty sets. Now here the relation means how two objects or elements are related to each other. So what it means relation? Relation means how two objects or elements are related to each other. If we consider a set of persons belonging to a family, then the relationship may be child of, may be mother of, it may be brother of, it may be father of, it may be sister of. This type of relations are there in one family or the relation between the members of two families also. But in mathematics, let A and B be two known empty sets. Then any subset of R of A cross B is called a relation, because in A cross B we are having always the ordered pair, and when we are talking about the relationship is always between two elements or two objects. Therefore, element of R should always be in the form of the ordered pair. So if A and B are two known empty sets, then A cross B is their Cartesian product having all the possible ordered pair of A and B. Then any subset of R of A cross B is called a relation from set A to B, and written as, we generally use this sign capital R for the relation. R is the subset of A cross B if R is a relation from A to B. Then we can also, element of R should be in the form of ordered pair. It means if element AB belonging to R, then we will write A is related to B. This is the common notation we are using in the question. AB belongs, here R is not the real number. Here R is, we are using for the relation. If R is a subset of A cross B, or if AB belongs to R, then we can say A is related to B. Similarly, let us see another in the language of maths. Let n be set of the natural number. I am defining the relation R has its cube S from n to n, set of natural numbers. Now, what possible ordered pair are there? It may be 1, 1. The cube of 1 is 1, cube of 2 is 8, cube of 3 is 27, and so on. Therefore, the elements in R Therefore, elements in R will be 1, 1, 2, 8, 327, because our relation has been defined as its cube S from n to n. Both the elements are from what? Natural number. So, therefore, the elements in the R may be 1, 1, it may be 2, 8, it may be 327. It can also be written R equal to, in step builder form, you can say XY, where X belongs to n, Y belongs to n, and Y equal to X cube. This is another notation to write down the elements in the relation. This is known as roster form, or this is, you can say, the set builder form that we have studied in the case of sets also. Now the next is, this is a simple meaning of relation. Let us know something more about relation. If R is a relation from A to B, then the set of first component of the ordered pair belonging to set A is called the domain of R. We have studied in the 11th class. So these words, the word is here, domain, codomain, and the range. Let me explain it again. If R is a relation from A to B, then all the element of R should be in the form of ordered pair. Then the set of first component of the ordered pair belonging to set A is called domain of R, and set B itself is called codomain of R, and set of all the second component of the ordered pair which belong to R is called the range. These are the three words. One is domain, another is codomain, another is range. Let me explain it with the help of example. Let A be a set having this element, B is the set having this element. Then I am write down R having these ordered pair. R is a subset of A cross B. So in R I have taken only these ordered pair. So R having these ordered pair. Now the domain of R, the set of the first component of the ordered pair. So it is what? 1, 2, 3, 7. It is a subset of A. Codomain, the set B itself is known as codomain. And range is set of the second component of the ordered pair is known as range. So it is what? Second component 2, 3, 6. So it will be the range of R. It is always a subset of codomain. Range is always a subset of codomain. So this is about what? Domain, codomain, and range. These two words are much more important, domain and range. The set of the first component of the ordered pair form always the domain. The set of the second component of the ordered pair in R always determine the range, and range is always the subset of codomain. Now here, let us see here another thing. The relation on a set. Let A be a non-empty set. Then a relation R from set A to itself, a subset of A cross A, is called a relation on A. In the last we have also studied the relation on N also, because we have taken the relation has its cube. So both the elements are from N. Similarly, the relation on a set A, let A be non-empty set. Then a relation R from set A to itself. It means a subset of A cross A is called a relation on A. Now let us see its example. Let A is a set having elements A, B, C. Now I have considered R here. I have taken all these ordered pair AB, BB and C. Sorry. Now in R I am having these set of ordered pair. Now R is the subset of what? A cross B. If I am making the ordered pair from this set, it may be AA, it may be BB, it may be CC, it may be AB, it may be BC, it may be AC, it may be ABC. Ordered pair we can make all the. Now here I am defining the relation on the set A. Therefore R is a subset of what? A cross A. So therefore now it is what? The subset of what? A cross A, because both the elements are from A. Therefore we can read as the R is a relation on A. Now here the word is the number of relation. Now here the relation itself are the subsets of A cross B. If A and B are two finite sets having M and N element respectively. Now earlier we have studied the number of A cross B equal to number of A into number of B, means M into N. Now itself the relation is a subset. In the 11th class we have studied the number of subset of a set is given by the formula 2 raised to power N. Now here the number of elements of A cross B equal to what? Number of A into number of B equal to M into N. Therefore, the number of relation is given by the formula. The number of subset of A cross B, it means 2 raised to power M into N, means the number of relation from A to B. If A has M elements, B has N elements. So, number of A cross B is M into N. Therefore, the number of relation from A to B equal to 2 raised to power M into